So good evening everyone. So welcome to my YouTube channel Math Saptaram. So today we are going to see properties of Jacobian. So properties of Jacobians. Okay. So property first. Property first. First property. What is that? If U and V are functions of x and y, then del u, del v, del x, it means Jacobian. It means Jacobian of u and v with respect to x into Jacobian of xy with respect to u and v is equal to 1. Okay. So let's prove it. How it will be proved? Proof del u, del u v, del x, del y into xy uv. What is this actually? This is equal to del u upon del x, del u upon del y, del v upon del x, del v upon del y. Okay. Into del x upon del u, del x upon del v, del y upon del u, del y upon del v. So now we can write how we can write this, because this is determinant of matrix, this one. So we can multiply this matrix and we can take determinant. This will be equal to, so del u upon del x multiply del x upon del u plus del u upon del y into del y upon del u. Okay. Then this is equal to del u upon del x. Okay. Del x upon del v. This is u. Okay. Del u upon del x plus del u upon del y upon del v. Now del v upon del x upon del u plus del v upon del y upon del u, del v upon del x upon del v plus del v upon del y upon del v. So now what is this? By chain rule, what is this? This is del u upon del u. And what is this? Del u upon del V. And what is this? Del V upon del U. And this is del V upon del U. Okay. Now what is this? I am taking partial derivative of u with respect to u. That is one. I am taking partial derivative of u with respect to v. That is zero. I am taking partial derivative of v with respect to that is zero. Partial derivative of v with respect to v, that is 1. So this is identity matrix. So what is the determinant of identity matrix is 1. Okay. So we have shown that del u del v Jacobian into del xy del u v u v is equal to 1. Okay. Now similarly, no, similarly, if u is function of x, y, z, v is function of x, y, z, and w is function of x, y, z. Okay, then Jacobian of u b w with respect to x, y, z multiply x, y, z Jacobian with respect to u v w, that is also 1. Okay. Similarly, you can write more variables for more variables. Okay. So this is two. Now we are going to see questions. So example one. Example one. If x is equal to uv and y is equal to u plus v upon u minus v, find del ub with respect to del x del y. We have to find this. So solution. So here it is easy to find del u del x del u del y del v del x and del v del y rather than finding del x del u del x del v del y del u and del y del v. So therefore we will calculate we calculate first del u b del x del y del xy upon del u v. Okay, that is equal to del x del u del x del v del del y upon del y del u del y del v. Okay, so what is del u? Del x upon del u. What is this? That is v. That is u. Del y upon del u. Del y upon del u. What will be this? So so del u upon del v. What will be del y upon del u? What will be this? You just calculate first. What is del u? Del y upon del u will be. It will be minus 2v upon u minus v का square. It will be. And del u upon del v will be 2u u minus v का square. Now solve it. What is this? So why this is? Because y is equal to what is that? U plus v upon u minus v. So we can calculate del y upon del u is equal to u minus v का square. So differentiation of numerator, that is 1 minus u plus v, that is okay. So what is this after solving? So u will be cancel out. So minus 2v upon u minus v square. Similarly, we can calculate del y upon del v. 2v 2u, it is 2v 2u upon u minus v का square. So after solving it, what you will get? 2uv upon u minus v का square plus 2uv u minus v का square 4uv upon u minus v का square. Now by first property of Jacobians, we have del uv upon del x del y into del xy upon del uv is equal to 1. We know this value. So value of del uv del x del y will be equal to 1 upon the value is u minus v का square upon 4u. So this is the answer. Okay, so this is the answer. So next, example number 2. If u is equal to x, y, z, v is equal to x square plus y square plus z square, and w is equal to x plus y plus z, find j is equal to x, y, z upon del u v w. Okay, you have to find this solution. So first we'll calculate this. What is this? U v w del x del y del z. So what is this? Del u upon del x del u upon del y del u upon del z del v upon del x del v upon del y del v upon del z del w upon del x del w upon del y del w upon del z. So what is this now? Y z x z x y. So 2x 2y 2z. And this is 1 1 1. So applying C1 is equal C2 is equal to C2 minus C1 and C3 is equal to C3 minus C1. What will be there? So this will be 0 0 1 2x y z and this is 2z minus y, sorry, so 2, so it will be 2z minus x, okay, and sorry, what it will be y z minus x, okay, so it will be z x minus y, but it will be 2 y minus x, okay. Now expanding, so from this row, you in this row you can take x minus y common from second column, and from third column you take z minus x common. So it is y z 2x 1, it is z, it is minus 2 0, it is y, it is 2, it is 0, x minus y z minus x. Now expand with respect to this and this with respect to third row. So what will get? It will be 2z 2z 1. Let me check it again. So we have this one. So y x, sorry. So y x minus z. So this is y x minus z we have. So z minus x, so it will be minus here. Okay. So 2z minus 2y it will be. So you take common minus 2. Minus 2 x minus y minus z, z minus x. Okay. Now by first property of Jacobians, we have del u v w x y z x y z to u v w is equal to 1. So this value we calculated. So now we can find this value. So what is this? Minus 1 upon 2 x minus y, y minus z, z minus x. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.